So, highlights from the chapter, the textbook, where your quizzes come from. How have you guys been doing? The quizzes have been, grades have been pretty good for the most part. No, there shouldn't be any crazy surprise questions, I hope. Most of the stuff, you realize the quizzes are coming from the textbook or this section of the slides. Not trying to trick you. Really not.
Just keep the confidence interval as it is.
Yeah. So our vocabulary, right? Population parameter, sample statistic, estimate. We've got our point estimate, and now we're moving into our interval estimates. The big thing with our interval estimate, it's a point estimate plus or minus some margin of error. Okay. Notation. So as I go through and I use vocabulary, I found that I was mixing up my vocabulary. So I'm going to try and be much more precise since we're teaching this for the first time. Or not the first time, but... So the point estimate, and I use the sample mean in this example, it could also be the sample standard deviation, it can also be a sample proportion. We'll start dealing with proportions more next week. The margin of error is represented by a big capital E. So our confidence interval, or our interval estimate, those two words can be used interchangeably, okay, as the point estimate plus or minus the margin of error. When we talk about a confidence level, confidence level is a 95%, a 99%, a 90% confidence level. When you talk about the confidence coefficients, you change it from a percent to a decimal. And I don't use the confidence coefficient a lot, but technically the confidence coefficient is used in the calculations. And then, how many of you guys are familiar with an alpha in terms of statistics? So we've seen alphas before. The idea of an alpha is, we'll have different definitions for it. We'll talk a lot about it next week. But for now, it's going to be the area that's left over from the confidence level. So it can be a 5% alpha level or a 0.05 alpha level. So 95% would be a 0.05 alpha level. A 99% would be a 0.01. It's just what's ever left over to make up 100%. So I've kind of already talked about it, but from a textbook perspective, we're talking about the probability that the value of our sample mean is going to give us a margin of error of some value or less. Okay? So we're assuming a normal distribution, right? So we're going to be talking about that sampling distribution of the mean. We're going to have a sample size that's bigger than 30. So we've got this normal distribution, so we can work with this. Okay? We can calculate areas under the curve. Straight up and down in the middle is our actual population mean. Okay? This interval contains our population mean. This interval doesn't. So is it possible to calculate a confidence interval that doesn't actually include your population mean?
Yes.
Sure. Right? We talked about the idea we take multiple samples. We get multiple samples. We get multiple point estimates. And for example, if one sample had the 83-year-old graduate in it, that mean is going to be skewed a little bit. Okay? That's why we take multiple samples. That's why we add the confidence interval to hopefully get a better idea. Okay? So really what we're looking for with a 95% confidence level, that's going to say that if we did 90 or if we did 100 samples and we created 100 intervals, 95% of those intervals would contain this true population parameter, and we'd miss 5% of the time. So that's really what that confidence interval is talking about. It's not just how confident we are that we're right. It's actually talking about getting the true population parameter in those intervals. Yes?
So in this graph, E is 2 sigma, right?
Yes. So as far as the calculation goes, well, that's just more saying it. So because 90% of all the intervals contain the population mean, we're going to say we're 90% confident that this interval includes the population mean. So that's kind of the interpretation piece. We have formulas. We have this, which you can use if we know the population standard deviation. There's some math behind it. We're not going to get into it. This is the formula we use if we don't know the population standard deviation. It's the same thing. The only difference is where you're calculating the area under the curve. Are you using a normal distribution, which we've already talked about, or are you using this thing called a t distribution? And what a t distribution does is it just takes into account your sample size. So there's actually a guy who, hold on, I have my notes, so you guys will be able to see this too. So I always forget his name. William Gossett. I shouldn't forget his name. He's a very important guy. He's actually the founder of the t-distribution. But he didn't want his name out there, so he actually just signed it student. And so that's why this is actually called the student's t-distribution. So like you'll notice a lot of the things we'll do, we'll talk about Cronbach's alpha. We'll talk about Pearson's correlation coefficient. When guys do things, they get their names attached. And yes, 90% of they're all guys. They get their names attached. Okay. Gossett didn't want his name attached, so he just called it student. So this is a student T. Right. The fun thing I learned about him, you guys can learn it if you read the book too. He actually worked for the Guinness Brewery in Dublin. Mm-hmm. That's where this came from. Right? Who knew you were doing normal distributions on beach? Apparently, the way everything works and settles is very important. Okay. So he was doing small-scale materials. He was doing temperature experiments. Right? What temperature makes the best beer? And that's where this kind of came from. Go William Gossett. So the idea, and as the sample size gets bigger and bigger and bigger, it actually is the normal curve. Okay. SAS assumes that we have a sample, and it always uses the t-distribution when it's doing its calculations. Okay. So the formula that SAS is actually using, I'll come back to it in a second. So when we're looking at these formulas, I told you it was the sample, or it was the point estimate, plus or minus the margin of error. Okay, so the margin of error is the second piece. And this margin of error is two parts. One is the standard error, right? So this right here is the standard error. And then you have something to do with the sample size and the distribution. It's made up of two parts. You don't need to know the parts because we're going to have SAS do this for us. But that margin of error equation comes in helpful. Because even though we said our magical number was 30, that's not always the case. Okay, sometimes we want to calculate if I want a specific margin of error, and I know I have a given standard deviation, then how many people do I need to sample to get that specific margin of error? Okay, so this happens a lot when you're doing polls, right? I'm okay, like, I'm trying to remember, the Gallup poll always has a plus or minus 3% margin of error. So they've got to figure out how many people they need to sample so that we get, with a 95% confidence, a 3-point margin of error. How many people do I need to sample? So if we take, how many of you guys love algebra? You're like, okay, I'm not going to admit it, but I kind of do. Right, so all we're going to do is just rearrange this equation, right? So the first thing we can do, if you believe me, is I can put z alpha over 2 over 1, and the equation looks like this. Then I can multiply by the square root of n, move it over. I can divide by e, the margin of error. And then if I take the square root, so if I square both sides, I can get rid of the square root. And then just to make the formula match what's in the book, yay, algebra. Yeah. So now my sample size, I can figure out this is more my confidence level plays in. I've got my standard deviation, I've got the margin of error I want, and I can tell you what my sample size needs to be. One of your homework questions will have you doing this. Okay? Here's the formula you're going to use. SAS doesn't do this part for you. You will need to use a calculator and this formula. It's only one question. It's on the homework. Not on the quiz. You'll have a quiz question about sample size, but you don't have to do any calculations on the quiz. Okay. You can do it. I even give you some helpful hints.